These notes are called molecular versus empirical formula. A molecular formula gives the real formula of a compound. These are the formulas that we've been studying all last semester and this semester so far. An empirical formula gives the smallest whole number ratio of atoms in a compound. So if we look at this picture right here, my molecular formula might be C8H16O8. But I can divide or reduce all of these by 8. And so if I do 8 divided by 8, I get C1. And 16 divided by 8, I get H2. And 8 divided by 8, I get O1. So the formula on the left side would be the molecular formula, but the reduced version would be called the empirical formula. It gives the smallest whole number ratio of atoms in the compound. So how do we convert from a molecular formula to an empirical formula? Well, all you do is reduce. So if I have H2O, remember there's no number after the O, so that's like there being a 1. Can I divide both of these numbers by a common number? No. So in this case, this is already the empirical formula. And sometimes the empirical formula is the same as the molecular formula. But if I look at number 2, I can divide both of those by 2. 2 divided by 2 would give me H1, or just H. And 2 divided by 2 would give me O1, or just O. And so my empirical formula would just be H and O. Here I can divide both of these by the number 6. 6 divided by 6 gives me C1, or just C. 6 divided by 6 gives me H1, or just H. And so my empirical formula is CH. O2, I can reduce that. I can divide by 2 and just get O. H2SO4. So remember, when there is no number, it's like a 1, and it usually helps to draw that 1 so that you don't forget that it's there. So if I tried to divide all of these, I cannot divide 1 by anything larger than itself. So this one is already my empirical formula. Now notice these are not all the same. So I have a 6, a 12, and a 6. I can divide these by 2. I can divide them by 3. I can divide them by 6. And so I should always divide by the largest common denominator. So by 6. So 6 divided by 6 gives me C. 12 divided by 6 gives me H2. 6 divided by 6 gives me O. Here I have C2H10, and in those look like they're divisible by 2, but remember my O at the end, there's only 1, and so I cannot divide those by anything. My empirical formula is the same as the molecular. K2CrO4, my Cr, there's only 1. Once again, this is already the empirical formula. So going from the molecular to the empirical is, can you reduce it? And what is the largest number you can reduce it by? Now, there are 4 steps to do the opposite, to go from the empirical formula to the molecular formula. And they are: 1, find the mass of the empirical formula. It's kind of like finding the molar mass, except now I'm finding it of the reduced formula. 2, divide the molar mass of the molecular formula, which you will be given in a problem, by the EFM. EFM stands for empirical formula mass. 3, round to the nearest whole number. Step 4, multiply times the subscript of each element in the empirical formula. You should make sure you have these 4 steps written down and follow them in each problem. Let's look at an example. It says, through experimentation, it was determined that a compound has a molar mass of 283.89 grams per mole. Its empirical formula is P2O5. What is the molecular formula? So we have 2 things that we know here. This is the molar mass of the molecular formula. So, and this formula is not the molecular formula. This is the empirical formula. So, step 1 was to find the mass of the empirical formula. So step 1 means that we're going to find the mass of P2O5. So we know phosphorus, there are 2 of them. Each one has a mass of 30.97. Oxygen, there are 5 of them, and each one has a mass of 16.00. Multiply and add those together. So 2 times 30.97, 5 times 16, add those, I get 141.94. That's step 1. Step 2. Is to divide the molar mass of the molecular formula by the empirical formula mass. So the mass of the molecular formula was 283.89 divided by the empirical formula's mass that we just calculated. And so if we do that, 283.89 divided by 141.94, we get 2.0000 and some change. So step 3 says to round to the nearest whole number. That means we're going to get rid of everything past all those zeros. So my nearest whole number was 2. And step 4 says to multiply the subscript of each element in the empirical formula. So if I start with P2O5, I'm going to multiply those times 2 and get P4O10. And that's my molecular formula. So if we look at one more problem together, we can say determine the molecular formula for a compound with a molar mass of 78.11 that has an empirical formula of CH. So step 1, find the mass of CH. So 12.01 plus 1.008 gives me 13.01. Step 2, I'm going to divide 78.11, the mass of the molecular formula, divided by the mass of the empirical formula we just calculated. So you do that. You get 6.00015. Step 3 is to round to the nearest whole number. So we're going to round to 6, get rid of all that stuff after the decimal point. And then step 4 means we're going to multiply each of these times 6. So C6, H6. And you're done.